So sound is waves produced, that's not how you spell it, there we go, by vibrations in matter. So when you let a balloon go and it goes all over the place, what you're hearing is vibrations of the air coming out. So vibrations of matter, vibrations of particles, and those vibrations are creating sound. When you slam something down, okay, you're hearing vibrations in that particle, and that releases sound waves. So sound waves are caused by vibrations in the matter, whatever the matter may be. Okay? What type of wave is sound? Garrett. Is a longitudinal wave. So the sound particles vibrate back and forth. So it's not this kind of a wave. It's the back and forth kind of a wave. Okay? Nice. So it's the back and forth wave. So when you speak, you push the particles forward, and then they hit the particles forward, and they hit the particles forward, and then they go back to their original position. So they go forward and back, that hits the next particle, forward and back, that hits the next particle, forward and back, and so on and so forth. All right, good. Number 3, let's define what it is. Pitch, Cannon.
It's the frequency of sound.
Yeah. It's the frequency of sound. So let's look at pitch. And we're also going to look at volume. God bless you. We're also going to look at volume. You'll need to get somewhere where you can see this guy. So if you're in the back, you may need to come up a little bit. If you're in the sides, you will probably want to come over. Because you need to be able to see this little bitty tiny screen. You can see this?
Yeah, a little blue, green line.
Okay, all right. So, got a little green line there. So this is an oscilloscope. Oscilloscopes turn input electrical signals into visible waves. And so the input signal is my phone here. So I just took a phone and I hooked it up to an electrical jack, and the electrical jack goes in here. And when I talk into it, it makes waves. Okay? And you can see the waves on the screen. Waves are just frequency. And so if you change the frequency, you change the sound that you're going to hear. So, for example, there we go. So, thank you. I practiced and practiced and practiced. So what I'm doing is I'm changing the size of this chamber. So when I change the size of the chamber, it's changing how big the waves are going to be. And that changes the frequency, which changes the pitch. So if you have a really high frequency, the waves are going to be really compressed together. That's this. And if you stretch it out more, the waves are going to be less compressed, and you're going to have a lower frequency. So that's what's going on. But in order to make this something that you can actually see reasonably well, we're going to use a tone generator.
It sounds like someone was dying.
No one's dying.
Are you sure?
Pretty sure. Okay. So, let's start at a fairly low frequency. I am. Okay, mastered the waves. So you can see there's a frequency here. And depending on what the pitch is, it's going to change the frequency of what the wave is. So if I increase the frequency, you'll notice the waves get closer together. Okay? This is 2,000 hertz. So there's 2,000 waves per second. So this is just showing you a really small one. So right now, I'm doing those sweeps. I'm doing, so what you're seeing is the screen is 0.5 milliseconds. So this is how many waves are showing up in 0.5 milliseconds. So obviously that's really, really small compared to the frequency, and that's so you can actually see them on the screen. And I can adjust this so you can see them differently, so you can see them more zoomed in or less zoomed in. Okay? So if I increase the frequency even more, probably had a nightmare like this once.
No. On mine tonight.
But you can see the frequency increase as it goes up. And if you're wondering, like, you're like, oh, that's really high. You can hear up to around 20,000 hertz. This is 3,000. Yeah, take it.
Do you know what like the hertz is for like the pitch that like the almost was on?
Yeah, it's like over 20,000. So this is 3,000.
Can you do over 20,000?
On this, no. This one only goes up to 10,000.
I say go to 3
Crank her up to max.
Hold on. We gotta like test hearing.
I mean, I don't mind.
This one is too high a frequency to show up on my thing. You'll all be able to hear this. 9,000 isn't that high compared to what you can hear. So there's 9,000 hertz.
Can anybody?
Or 10,000 hertz.
Can you hear it?
I can barely hear it though.
Well, I've turned the volume way down.
Tom, turn it up.
Crank it.
Yeah, crank
Just
it.
crank it. Yeah,
I want to be done.
there you go.
Somebody like the class.
One of those horror movies. Let's go back to something reasonable. So let's look at the second thing to talk about, and that's volume. So how loud something is. So you can see when I increase the volume, I'm increasing the amplitude of the wave.
I thought amplitudes don't
So amplitude does not get affected by frequency. At least in general, it doesn't get affected by frequency. So if I increase the frequency, you'll notice the size of the waves basically stay the same. Okay? But if I change the if I change the volume, I change the size of the wave. So amplitude is volume and pitch is frequency. Amplitude is volume and frequency is pitch. And that'll affect the different things that you see. So you can go back to your seats here. So let's just really quick, 4 and 5. It's not very long. So what's the difference between a wave of a high-pitched sound versus a wave of a low-pitched sound? So a high-pitched sound is going to be a high frequency, and a low-pitched sound is going to be a low frequency. And a loud sound is a high amplitude. And a soft sound or a low sound is going to be a low amplitude. So the volume, the loudness, the energy of the wave is dependent upon the volume. The energy is dependent upon the amplitude. And the frequency is dependent, the pitch is dependent on the frequency. So if I talk in a high-pitched Mickey Mouse voice, I'm increasing the frequency that my vocal cords vibrate at. If I use my basement voice, then I'm decreasing the frequency. Okay? Next time we'll finish up these, and we'll watch a video on Friday.
Yay! Mommy!
What?
MythBusters.